Hello, welcome to the video for surface area and volume for composite solids. Surface area and volume of composite solids. What is a composite solid? Well, the definition of a composite solid is a solid made of two or more well-defined solid objects. Finding the total surface area of a composite figure is similar to finding the surface area of three-dimensional figures, such as prisms, cylinders, pyramids, cones, and spheres. These shapes are combined to make three-dimensional figures called composite figures. To find the surface area of a composite figure, we'll follow some steps. First, identify the different parts the composite is made of. So, for example, this house is made up of a prism, a square prism or rectangular prism, and a pyramid, and they're connected. We want to identify the hidden surfaces. So, like the bottom of our pyramid and the top of our prism may be hidden. Find the lateral area of each part. Then we'll find the area of the non-common bases. For example, the bottom of our prism is not common with the top. And then we're going to find the sum of all the surface areas of its parts. So after we've calculated all the lateral areas and all the non-common bases, we'll add them all up. Let's do an example problem. The figure at the right represents the water tower in New Braunfels, Texas. It is a composite of a cylinder and a cone. The City Council has decided to repaint the entire outer surface of the water tower. All right, so we will determine the surface area that will be painted. So our first step is to identify the different parts of the composite is made of. And it's set up in there in a cylinder and a cone. But here's our cylinder and our cone. All right, now let's identify our hidden surfaces. So the outside of the water tower, underneath the cone and on top of so we're going to say the base of our cone and the top base of the cylinder. These are hidden, so we will not need those. All right. So now we're going to find the lateral area of our cone. So from here, we get our formula. The lateral area of a cone is pi r L. And so here, do we have all of our parts? We wonder if we have that. So we have pi. Our radius is 16. And the slant height is 20. Okay, so let's do the math on that. We have 16 times 20. That's 320 pi feet squared. All right, let's do the lateral area of the cylinder. So that formula is 2 pi r h. So we have our radius, which is 16, but we don't have the height of, oh yes we do, we have the height of our cylinder, it's 30. Okay, so we have 2 times pi times 16 times 30. And that equals 900 pi feet squared. All right, let's look at the base of our cylinder. Well, the cylinder is a circle, and we're going to go with the bottom base, but it's the same size as the top one. Both have a radius of 16. Okay, so it's the area of the base is pi r squared. So 16 squared is 256, and then that's pi feet squared. All right, and then for our total surface area, we just have to add all of this together. So we've got our lateral area, of the cone, the lateral area of the cylinder, and the area of the base of our cylinder. So that's 320 pi plus 900 pi plus 256 pi equals 1,476 pi square feet. Okay, well, that doesn't make much sense when we're buying paint. So let's go ahead and multiply that number by pi, and we get approximately 4,636 square feet, almost, so 854. Okay, so that makes more sense, 4,636 square feet. All right, so important thing to think about is anytime you have a surface area of a composite figure, you want to know if the top or bottom is open, if there's any opening or common side. Only the areas of the non-common sides are going to be found. Okay, so it's important to consider that. Finding the volume of composite figures is like finding the volume of each individual solid figure. These individual solid figures, such as prisms, cylinders, pyramids, and cones, and spheres, are combined to make three-dimensional solids called composite figures. So to find the volume of a composite figure, we identify the different parts of the composite made, and then we find the volume of each part, and lastly, find the sum of the volumes of all of its parts. So like, for example, this house, it looks like a triangular prism, okay? And it looks like it has a rectangular prism on there as well. It's got 4 columns, which are cylinders, and it's got a pyramid here. So we could find all of those volumes and add them all up and know the volume of this figure. Well, let's return to our example of the water tower. The figure represents the water tower for a local town. Climatologists are forecasting a drought, and the mayor of the town wants to know how much water the water tower can hold when it is completely full. Determine the volume of water that the full water tower can hold. All right, so we're going to identify the three-dimensional solids represented in the figure, of which I know how to find the volume. So we do have a cone and a cylinder. All right, we're going to determine the volume of the cone. Identify the formula for the volume of a cone. All right, my formula is volume for the cone is 1/3 pi r squared h. 1/3 pi r squared h. So we need our radius and our height. So we have the radius and we don't have the height. So we're going to have to find that. Okay, so let's move this over here. To find our height, we have our slant height, which is 20, and we have our radius, which is 16, and we're going to find our height. Okay, so I'm using the Pythagorean theorem. So we have 400 equals 256 plus h squared. We're going to subtract 256 from both sides and get 144. Take the square root of that, and we get 12. All right, so we have our radius, and we have our height is 12. Okay, so let's figure out what the volume of the cone is. So 1/3 pi 16 squared times 12. And so that's going to equal 1,024 pi. And that's in feet cubed. Okay. Now we're going to find the volume of our cylinder. And that formula is pi r squared h. So we already know that our r squared is going to be 16 squared, and our height is 12, and that's 3,072 pi feet cubed. So now we just add these two together to get the sum of our volumes, which is 4,096 pi feet cubed, and that is also known as about 12,867.584 cubic feet of water that the water tower will hold.